There are millions of people really heavily affected when we fail here. Okay, now we come to the tests. Testing is always essential to ensure quality. We can discuss if you test everything, if you test all use cases, or if you test every path of your execution, or if you cover really every code that you have. For the Java runtime environment, and this is what we do here, we extend the Java runtime environment. We all have to understand that this code runs on millions of devices, possibly billions. And there are millions of people really heavily affected when we fail here. So certainly OpenJDK wants you to test much more, not really every execution path, but well, much more than the average application programmer would actually test. Typically, application programmers only test their use cases. So if the use case is good, then everything is fine. We will go into this code here and we will see. We will test really thoroughly. So what we actually test is, let me start with the first test. That actually a null pointer exception is fired when we are going into the transferTo method with a stream of null. Now you will think, well, one check is enough. Well, actually the OpenJDK team wants 3 checks, with an empty stream, with a stream having only a single byte, and with a stream having actually 2 bytes. And don't ask me why. Actually, I copied this requirement. If you do know actually why they are testing this with a 1 byte and a 2 byte stream, I would be really happy if you could tell me. Actually, I did it because they asked for. They want these tests. So send me your opinion on that. Write it in the comments. The next test is that we actually want to compare the streams, which means the ingoing and the outgoing stream. So we really want to be sure that everything is correctly copied, not just the same number of bytes, but really the content of the bytes. And this is not easy if you just use null bytes. So we use random bytes. So the problem with random bytes is it randomizes your test, and randomizing a test is a very bad thing, because imagine the following problem. This code is tested once, let's say, per hour. So that there is a CI going on and everything is fine. The bar is always green, the server is always happy. But then suddenly, after weeks, you get an email that this test is broken. So you start it again and it's green again. What is good for? You go into the code, you will notice it's randomized and you cannot repeat it. Holy shit. Holy shit. So never randomize your tests. Make them use random numbers, which is something completely different. The random numbers are good because we can see the position where something fails, but we must not really use real random. We must ensure that it's the same numbers always. And how's done that? Because let's go into the implementation. We have a method which is creating random number with a class that it's written by the OpenJDK team. Sorry, this is the wrong one. So here it is, the random factory. The random factory does a trick. It provides a random seed number, a starting point. It's randomized, but it prints the starting point, the seed number, in the output. So when your test fails, the log says it fails with this seed. When you're setting this seed again, which you can do in JTRAG using -d, you pass in the seed. Then you can actually repeat the test with the same, always the same random numbers. So this is the difference between randomizing the test and using random numbers with a guaranteed seed. So we can reproduce it, and we have random numbers to be able to actually compare really bytes and not just null bytes. What's next? We are doing different checks. We check at the very first an empty stream. There's not a single byte in it, so this simulates an empty file. Maybe there is something broken with empty files, because if you look at the source code, so if initial pos is 0, that might impose a special condition. So it actually is not the case, but maybe I changed the code. So 0 is always a tricky thing. So next we do is we create random bytes, and we try to use a bit random here to not always have exactly the same number, 1024. We can enlarge it up to 4K. By the way, 4K would be, in at least on Windows, the size of the NTFS bytes of the NTFS file system block size. So this is what normally would find most failures, if there is a failure in my source code. Actually, there is none. But there are more side edges we want to check. So, for example, what is if we need more than one block? So this might be a thing depending on the implementation. Actually, my current implementation is safe in this case, but the original implementation is not. So here, sorry, this one is not. So my test is testing not only my change, it's testing the complete transferTo method. And inside here is a loop that uses smaller blocks. So we have seen it is 8K. So here we are sure at least 16K are used. So we are sure that if there is a problem with using multiple iterations, then this will detect it. So then we have something with the starting positions. There could be in theory a bug. Let's go here with correctly dealing with the starting positions, either in the implementation of transferTo, which is not a direct jump into the operating system. It actually has Java source code. So you can see it here. Let me show you. So it actually has Java source code, right? And the Java source code is routing into the operating system. So there could be, in theory, a problem that we will only see if we don't start really at the byte number 0. If we start in the source, for example, in byte number 1000, possibly there could be a problem. The same could happen in the target. So there's a difference if you have a target file that is empty, where you are in a situation of writing into an empty file, which is a different situation to writing into a file that already has content. So what you want to ensure is not to overwrite the content, but really extend the file by appending bytes. So you can see here that this test is not actually just testing the API. It's required that you actually make up your mind about test cases of potential fails. So the OpenJDK team was very eager telling me things that could fail in theory by that code. So this is what makes testing much more complex. So we have 10 iterations here about file size between 10,000 bytes up to much more. So this is what does the site, the edge cases. And there are more edge cases. Specifically, there is a test writing beyond the source file's end of file. That could actually happen. I didn't think of that case before, but actually it could happen that the source file is positioned past its end. How is that possible? Well, you take the stream, read it completely. It's empty then. Empty. Well, it's a file. So you're at the end of the file. And then you start a transferTo method. And we want to be sure that in this case, nothing bad happens. So actually, what is expected to happen here? That 0 bytes are copied. It shall not fail. It shall not throw an exception. It shall not copy rubbish. It shall really copy 0 bytes. So this is what we do here. And the next check is next side cases that what happens if the target is beyond its end of file. So this happens when you have a target file and position the right pointer past the end by calling append on that file and then invoke transferTo. So we want to be sure that it does not overwrite something, that it crashes or something, but really appends to the end. And now you could think, well, how is this comparison actually working? And this you can find here. We call check transferred contents. This is just a default. If we want to have a start at position 0, and the actual method is this one. So this is really complex. And why is that so complex? This is because this test is modular. It's not just for files. I intend to do much more than file testing with this one. And in future, it shall also test, for example, sockets, non-blocking sockets and all that. And there is no file then. So if you want to just check file copies, this thing is easy, but this test is not for files. This is already prepared to check non-files.